All right, let's dive in. We hear about AI in our cars, on our phones, pretty much everywhere. But it's also quietly becoming one of the most important co-pilots in the sky. We're talking about one of the most complex and safety-critical industries on the planet, aerospace. And this isn't some far-off future prediction. It is a transformation that's happening right now in cockpits all over the world.
And look, this isn't science fiction. This is the reality for pilots today. This quote from an Indian Air Force pilot just nails it, doesn't it? The cockpit has gone from this panel of analog dials and switches to a digital nerve center, and AI is the quiet partner working in the background, making sense of it all. So this big shift is really happening across two parallel universes in aviation. On one hand, you've got the commercial planes we all fly in, and on the other, you have the high-stakes world of military jets. The tech might be similar, but believe me, the goals and the risks are completely different. So let's start with the world most of us know best, civil aviation. Here, AI isn't about dogfights or stealth missions. Nope, it's all about making every single flight that much safer, more efficient, and maybe even a little bit greener. AI's impact actually starts way before you even get on the plane. On the ground, AI-powered computer vision is speeding up things like automated baggage screening and just generally beefing up security. But its most important job, well, that happens thousands of feet up in the air, and it's fundamentally changing how planes are maintained and flown. So what does that actually mean? Well, for decades, maintenance has been mostly reactive. You fix something after it breaks. But AI is allowing this massive shift to predictive maintenance. It's constantly analyzing these streams of data from sensors all over the aircraft. We're talking temperature, vibration, pressure, and the algorithms can spot a potential failure before it even happens. And the results are, well, they're staggering. AI-driven predictive maintenance can cut an aircraft's downtime by as much as 30%. For an airline, that is a huge deal. It's a massive boost to their fleet's readiness and a huge cost saving. It just means more planes are ready to fly safely at any given time. And up in the cockpit, AI is making the flights themselves smarter. These enhanced flight management systems, think of them like a super intelligent GPS for the plane. They're constantly chewing on data, weather patterns, air traffic, the plane's own performance to find the absolute most efficient route, moment by moment. That cuts down on fuel, reduces emissions, and hey, it often makes for a smoother ride for all of us. Aerospace engineer Srishti Rawal really puts it perfectly here. The key takeaway is that AI isn't just doing one little thing. It's making the entire, incredibly complex system of commercial flight smarter, more adaptive, and more efficient. But efficiency and safety, that's only half the story. The same core technology is being pushed to its absolute limits in a totally different arena, the military battle space. Here, the applications might sound similar, but the stakes are exponentially higher. Think about it. A modern fighter pilot is just bombarded with this overwhelming storm of information. So the main job for AI in this world isn't really to fly the plane. It's to help the pilot make sense of all the chaos. It's about cutting through the noise to give them a clear, actionable picture of what's going on around them. So how does that work? Well, the AI basically acts as this incredible fusion engine. It sucks in data from dozens of separate sensors, radar, infrared, electronic signals, you name it, and merges it all together. It turns that flood of raw data into one single coherent picture. This lets the pilot identify, track, and prioritize threats way more effectively than any human ever could on their own. India's upcoming AMCA fighter jet is a perfect example of this. Its AI-powered electronic pilot is going to do things like automatically identify targets, give the pilot decision support in those split-second critical moments, and even create a synthetic view so they can navigate in zero visibility. This is AI as the ultimate wingman. And this same technology is already paving the way for ideas that were just pure science fiction a decade ago. We're talking about autonomous drone swarms, robotic wingmen that fly alongside manned jets, expanding the pilot's reach. Projects like CATS and ALFAS in India are already developing this stuff. It's happening. So we have these two worlds, civil and defense, and they're both racing ahead with AI. But they're both running smack into the exact same fundamental roadblock. And it all comes down to the challenge of trusting something you can't fully understand. This quote just nails the problem. We call it the black box issue. With deep learning, we know the AI model works, we can see the input we give it, and we see it gives us the right output. The problem is we often can't explain the logical steps it took to get there. And in an industry built on safety and traceability, well, that's a huge problem. And this leads us to the billion-dollar question that regulators and engineers are wrestling with right now. I mean, how on earth do you give a safety certification to a piece of software that can basically rewrite its own logic as it gets new data? The old rulebooks they don't apply anymore.
At its heart, the problem is that the software just works in a fundamentally different way. Traditional aviation software is what we call deterministic. It follows a strict, predictable set of rules. You can test it. AI, on the other hand, is data-driven. It's probabilistic. And while that makes it incredibly powerful, it also means it can act in unexpected ways in rare situations. You literally can't test for every single possibility.
And this technical black box problem creates a very, very human one: trust. Imagine you're a pilot in a high-stress situation. The AI gives you a recommendation, but you have no idea why it made that choice. Are you going to follow it? Probably not. Without transparency, you can't have trust. It's that simple.
Which brings us to the guiding philosophy right now for how to integrate AI. Instead of thinking of AI as some autonomous decision maker, the goal is to design it to be more like a transparent, super advanced sensor. It provides data, it highlights things, it offers suggestions, but it supports the human. It doesn't replace them. At the end of the day, the goal is human-machine collaboration. AI is there to enhance the pilot's abilities, but the human keeps the ultimate authority and, just as important, the ultimate accountability. For now, the human has to stay in the loop. But that leaves us with one last big question, right? Human in the loop is the answer for today. But as these AI systems get exponentially smarter, as they process information way beyond human speed or comprehension, that line between co-pilot and commander, it could start to get a little blurry. Which makes you wonder, in the cockpit of the future, who or what will really have the final say?